Hello and welcome back to another great video. So in this one, we are going to look at why are operation tokens necessary and especially what are operation specific tokens, right? So I myself went on this journey because I am following OWASP secure coding checklist, right? So if you go to this particular checklist, by the way, the link is in the Medium article. So if you like reading articles, you can go there. If you like watching me talk to you about stuff, you are already here. So this is the checklist that I was going through, and somewhere down the line in this checklist, there's something written such as this, that you need to supplement session management for sensitive server-side operations, yada yada yada. Now all this will sound quite random to you, right? But let me break it down for you in very simple terms, right? Okay. Now imagine you have an application. It has a client side, it has it has a server side, right? So let's name this as client, name this one as server, right? Now usually what happens when you send a request from client to server, you need to verify that the request is coming from a legitimate source. To do that, what do you do? With your request, you send in the payload, you ask for an access token, right? So if I mention it with more specification, it is basically user specific access token. So that means each user will get an access token, right? And that they will use that access token again and again to basically prove their identity. Usually it is assumed that user will keep this thing a secret, right? Now what will happen when you have a malicious entity in between, right? Or you have a malicious entity in between which is looking at your access token, right? So before I tell you about this, let me tell you how it works. So basically what happens when a client logs in for the first time, it connects with the server, it asks server to authenticate itself, and server returns the access token, this access token that we are talking about. And then it is stored in this client's local storage. So if I show you here, imagine that this green box, right? Imagine that this green box is the client's local storage. So it is stored in client's local storage, access token, right? So now the access token is stored in the client's local storage because we don't want the client to again and again authenticate uh, and fetch the access token every time it needs to send a request, because then for each request you will be sending one extra request, making the whole application slow, right? So that's why what we do is we get the access token, we store it locally somewhere so that we can reuse it again and again until it expires. Now all this makes sense, not a problem, right? Now usually the problem appears when we are on a web application. So for assume that this access token was basically made for a website called abc.com, right? And it makes sense. Okay, abc.com is our website. It fetches the access token from the local storage and sends it ahead. Not a problem, right? Now tomorrow this same client, yeah, you know what? Let's show the client as a human, right? So this is our client. I will color him something different. Yeah, yellow. Yeah, this is our client, and these are the websites that he's trying to access through his browser, right? And this is the local storage. Okay, makes sense. Makes sense. Shouldn't be a problem. Now, what happens is the flow is same, right? Client goes to the website tries to log in the client. Once he logs in, the access token is reshared and is stored in local storage. No problem, right? And basically abc.com has access to this access token. Cool. Now tomorrow what happens is client goes to some other website. Client goes to a website called xyz.com, right? Let's send the client here. Now client visits this website. This website internally sends a request to abc.com's API, right? Now client does not know this because all this is malicious. This hidden request is made in such a way that that xyz.com will be able to do some malicious REST API call, malicious API request to the client's account via routing it through abc.com, right? So when xyz.com makes a request to abc.com, and abc.com, since it has access to the access token, it will fetch it and send a request that was not authorized by the client, right? So it will send a request like this, which is malicious in nature. Let's push it here so you know what is happening, right? So this is the malicious request, right? So this is the malicious request that happens and which can result in operations that are very sensitive, very critical to a client, right? This is a breach of privacy. This is kind of identity theft, right? So now this problem that I told you, where a client's access token is stolen without their knowledge, right? It is known as, oh, just a second. Yeah, it is known as CSRF. How can I type it here, man? Yeah, oh shit, found it. Yeah, so it is called cross request. Yeah, it is just let me. Yeah, it is called cross site request forgery attack, right? So cross site request forgery, that is CSRF, correct? So cross site because a request from site one which was not supposed to send a request is sending a request internally using another site, and a fake request is being sent. A request that was not supposed to happen, that was not legitimate, was sent to the server, which made some actions that shouldn't have taken place, right, which are malicious. Now this is called a CSRF attack. So how do a system like this save itself from such requests being happen, such forgeries taking place, right? So to do that, what we have is a concept called operation specific tokens, right? So you have a website, each website has n number of operations, right? So let's take one sensitive operation such as delete the account, correct? Now it would be a big problem if you visit xyz.com and it deletes your account on abc.com, which should not happen, right? So to protect us against it, what we do is we embed a special token that is hidden from the that is not shown in the UI specifically, but is embedded in the HTML of the website. So imagine, let me draw it for you, right? So let's change the color to I think it's a violet or purple. I don't really know honestly. Yeah, so this is your website, right? There are a lot of things on your website, but one thing that is present is an input box, right? And yeah, this is the input box which is pre-filled with an operation specific token, right? And it is not visible to the user, it is not visible to me as a person who is visiting the website. And basically this is, you can call it as abc.coms slash delete, right? So this is a web page which corresponds to abc.com slash delete, right? And it has an operation specific token embedded inside it, right? And now what happens is, so if somebody else and basically this particular website, what it does is it sends a request to your server. Now let's draw a small server as well. Server was white in color, so we'll draw it in white here, right? So this is a server, this is your website slash delete website, right? And internally, now whenever somebody submits a delete request on this web page, it calls delete account API, right? And which basically internally deletes a user's account. The flow is pretty simple and makes sense. Now, when this API is called, with it a few things are sent. One is the access token that we knew that was already there, right? So there's this access token, a user's access token. So that is sent, and with it we are also sending this operation specific token. Cool. Now, why is this important? So when you send this operation specific token through an API, it verifies two things. It verifies that the user is legitimate. It verifies that the correct operation is taking place. And the third thing that is verified is that a third party, if a third party website, right, such as xyz.com. So let's bring xyz here again. So if xyz.com attempts to basically call our server using by doing something like abc.com/ right, delete account API, right? So the only thing that it has is the user's access token, user specific access token, because it was present in the local storage. Whereas it does not have the operation specific access token that was embedded in the website. So basically you are restricting your APIs to only work if they are sent through your web page, sent through a website, right? So this protects your server, or it helps your server to basically verify that the person who is trying to make the request is a legitimate user, is a user coming from our website and not somewhere else, right? So that is how operation specific tokens help you to verify, help you to protect actually against the CSRF attack, that is cross-site request forgery attack. So now the request forgery is not happening. But you might wonder that, okay, Apurva, now what you're making, what you're saying does make sense. But what if I have a man in the middle, a malicious party, right? So I'll call it malicious party, right? Which somehow gains access to this information, right? Which somehow finds our access token and the operation specific token. Oops. Anyway, yeah. Assume that I have an arrow here, man. Okay. So this malicious party was able to see the access token and gain access to the operation specific token as well, right? How would I protect against it? So the way you protect against it is simple, right? So what you need to do is, if you remember right, this is a web page, right? And web pages are served by a server, right? So when this website was rendered for the first time, it was sent by the server. Now when a server is sending this web page, this operation specific token is actually embedded by the server, right? So server basically generates this. How can I bring it up here? Oops. Wait a second. Anyway, so this particular operation specific token is actually generated by the server. And when I say it is generated by the server, that means this operation specific token is a random generated token, and it is only valid for, well, one use, right? And when the server sends this operation specific token and embeds it in our website, right, the user can use it to send a request to our back to the server for any critical activity. Now, if a malicious party finds this operation specific token, right, it will have a problem reusing it, because as I told you, it can only be used once per website, per web page, correct? And it is randomly generated, so it won't be predictable. We are assuming that it won't be predictable. You might also ask me, Apurva, since the server has sent the random token to our web page, right? How would it verify when it receives the same token that it is legitimate or not? So whenever a random token is generated, make sure that you also store the same token in your database, right? So for temporary mapping, that is. So that's why the actual picture should look something like this. The random token is generated here, and the random token is also sent to the DB for persistence, so that tomorrow when I receive a request, I fetch the operation specific token, I verify it against my DB. If everything is correct, then and then only the request is processed or it is rejected. And this is why operation specific tokens are so important. I hope you found something useful through this video, and let's talk again next time. Oh, by the way, make sure to like and subscribe and see everything you see on the screen, right? We are already at 19 subs. I just need one more sub to reach my 20 sub mark. So please do your bit. Cool. Bye.